The first question says, an amateur rocket is launched vertically upward from the surface of the Earth. The rocket reaches a velocity of 120 meters per second at a height of 450 meters. At that moment, an empty fuel unit is disconnected and released or dropped. Ignore all effects of friction. Question number 1 says, what is the velocity of the empty fuel unit relative to the ground the moment it is released? How do we answer these questions? The first thing that you do, you underline what you think is important. An amateur rocket is launched vertically upward, which means the rocket is moving upward and from the surface of the Earth. Then the rocket reaches a velocity of 120 meters per second, which means at this point, let's assume at this point, the velocity is 120 meters per second. And also the height from here to here, it is 450 meters. And then at that moment, an empty fuel unit is disconnected and released. Ignore the effect of air resistance. So what you are given here, you are given the velocity at the height of 450 meters, and then the magnitude of the velocity is 120 meters. Now the first question is, what is the velocity of the empty fuel unit relative to the ground the moment it is released? It is clearly stated here. The rocket reaches the velocity of 120 at the height of this. And also the rocket was launched upwards from the surface of the Earth. So the magnitude of the answer for the magnitude of the velocity will be 120 meters per second. You were given the answer. Then the next question will be, calculate the maximum height that the released fuel unit reaches. Now, we are required to calculate what? The maximum height. So what is important is when the rocket reaches this point, it had the velocity of 120 meters per second. But now, when the engine or when the fuel was emptied, that's when it went up to the maximum height. And at the maximum height, the teacher should have told you that the velocity is equal to 0 at this point. So for you to be able to answer these questions, just divide your graph, that is a rough sketch, into sections. We will have the first section, which is A to B. From A to B, that's when the object started moving from the ground up until this height, and also from B to C, the object have moved now from point B and reached the maximum height. Then, what does this mean? The question said, calculate the maximum height. So, which means that the released fuel unit reaches. Then, which means we are going to calculate what? Delta Y. So, let's look at what we have. The first thing that you do, data, we have the velocity of 120 meters per second. But not forgetting, out of our equations, we have two velocities, initial velocity and the final velocity. So you have to ask yourself, at this point, what is the magnitude of the velocity, this velocity? Is it the initial velocity or final velocity? Then because we are now concentrating on the maximum height, then this will be our initial velocity. This means that because the rocket reaches the maximum height, the final velocity will be 0. Then, what is it that we have again? From this point, we cannot use this delta y. Why? Because it is only the distance until the fuel was emptied. Then we are calculating delta y from point B to point C. So we are required to calculate delta y. Then we have our acceleration. Why do we have an acceleration? It is because now when you go back here, the empty fuel was disconnected. So which means from this point to here, this point to here, the rocket is in a free fall state. So hence we will use our 9.8. But from point A to point B, we cannot say the rocket is in a free fall state, because the fuel, it is still the one that is doing the work that makes the rocket to move upward. Then we come back to our equations. We wrote our data. Then we must write our 9.8 meters per second squared. The equation, we must choose the correct equation now. We are calculating, you must make a decision now. We are required to calculate the displacement up to the maximum height. Now, the first question is equation. Can we use this equation? We cannot, because delta y is not in this equation. Can we use this equation? Yes, we can use it, because in our data we do have VF, we do have VI, and also acceleration. So the only unknown that we do not have is delta y, of which it is what we are required to calculate. But let's move on and look at this equation number 3. Can we use equation number 3? We are required to calculate delta y. Yes, we do have our initial velocity, but we do not have time. So it's impossible for us to have two unknowns in one equation. The same goes to the equation number 4. We do not have time and also delta y. So when choosing the correct equation or the suitable equation for calculating delta y, we cannot use an equation whereby we find ourselves having two unknowns in an equation. Now, we said that we're going to choose the equation VI squared plus a 2a delta y. Then our VI is 0 squared. Guys, do not forget that when you write the equation, you should write it the way it is from the table of formula, so that you do not forfeit the mark that you are given when you write the correct equation. And also, our VI is 120. So the other thing is, do not include the units when you substitute. Just write the magnitude. And then this 2 times 9.8 delta y. There is something that I know you are thinking of. The substitution is correct, but the direction makes this substitution to be wrong. Remember, the rocket is moving upward. So when the rocket is moving upward, we must choose a direction. So if you choose positive as upward, which means everything that goes down will be negative. So our rocket is moving upward. So at this point, it is where the initial velocity is. It will be positive, but the acceleration, the direction of the acceleration do not change. Gravitational acceleration takes the direction of FG, which is downward. So if the rocket is moving upward and we use point B to point C, then which means our acceleration must be negative. So you must always be alert that when the object is projected upward, the signs or the direction of the initial velocity must not be the same as the direction of the acceleration. Then when you do your mathematics, you will know how to use the calculator. After calculating and doing everything with your calculator, your answer will be 734.69 meters. It is positive. Why? You're going to transpose this side to the left hand side, and also it's going to change the sign. The 19.6 delta y is going to change the sign, it's going to be positive. Then your answer will be 734.69 meters per second.